This is the last video for Test 3 review. We're going to focus on finding the horizontal asymptotes of rational functions. We talked about at the end of the last video that a rational function is one that looks like a fraction. And again, sometimes with those rational type functions that look like fractions, we have to avoid certain numbers because of the relationship or because of the fact that it is a fraction. And so there is a possibility that you have a horizontal asymptote that runs left to right and is a value or values that you have to avoid for that particular function. Now, they try to summarize it there in the paragraph for you, but I want to try to write it out maybe more in a lingo or in a language that would maybe perhaps make more sense to you. And so we're going to begin with that. Basically, to decide, first of all, whether or not you have a horizontal asymptote, you compare the degree or the highest exponent in the numerator to that one that's in the denominator. Okay, so we want to look at the degree of the numerator. And remember, the degree is the highest exponent. We're going to call this n for now. We also want to look at the degree of the denominator. And to try to make it shorthand for us to write it out, we're going to call this one d for denominator. And so when you look at the relationship between those degrees, one of three things is going to happen. Either the degree of the numerator is less than the degree of the denominator. If that's the case, there is a horizontal asymptote that exists, and that horizontal asymptote is your x-axis, or the equation y equals 0. It's possible that the degree of the numerator is the same as the denominator. They're equal. In that case, there is a horizontal asymptote as well. And that horizontal asymptote is the leading coefficients of the numerator and denominator. So remember, the leading coefficient is the number in front of the x with the highest exponent. So it'd be the leading coefficient of the numerator over the leading coefficient of the denominator. It's the ratio of those two numbers. The third option is that the numerator is greater than the denominator. In that case, there is no horizontal asymptote, but there could be what's called a slant or an oblique asymptote. Now, to have a slant or an oblique asymptote, basically what has to be true is that the degree of your numerator is the denominator plus 1. If your exponents make this red statement true, that the degree of the numerator is 1 more than the denominator, then you have no horizontal but a slant asymptote. You'll never have both. You never have a horizontal and a slant asymptote. It's an either or situation. So the example that they have on your review sheet says find the horizontal asymptote of the function f of x equals 3x to the third plus 7x squared plus 8x minus 4 divided by 5x to the third minus 3x squared plus 2x minus 5. So if I look at, in this case, the degree of the numerator, which is the highest exponent, so the degree of the numerator is 3. The degree of the denominator happens to also be 3. And I compare those. The degree of the numerator compared to the numerator, 3 equals 3. So I know that a horizontal asymptote does exist, and it's going to equal the ratio of the leading coefficients. Now remember, your leading coefficients here are the numbers in front of those high exponents, which would be 3 and 5. So my horizontal asymptote is y equals 3/5. And that's how you find the horizontal asymptote for a rational expression or a rational function.